Class, this is the first video from section 6.5 in your note packet on definite integrals. And in this section, we are evaluating definite integrals using the U substitution method. So in example 1 down here, we have to evaluate the definite integral from 0 to 2 for the function x squared times x cubed plus 4 to the 5th power with respect to x. Well, you will note in parentheses here, the derivative of x cubed plus 4 is 3x squared. Well, we have the x squared, we don't have the 3, but we can still use the U substitution method to evaluate this definite integral. So we set U equal to x cubed plus 4, what's in parentheses here, and the derivative of U with respect to x is equal to 3x squared, and then we multiply both sides by dx. The dx's cancel on the left, and we have du is equal to 3x squared dx. Now we divide both sides by 3, and we have 1/3 du is equal to x squared dx. So now up here in our definite integral, right, we can switch the order of multiplication inside the integrand and write it as x cubed plus 4 to the 5th times x squared. And now when we do our substitution, replace the x cubed plus 4 with u, and we have u to the 5th power, and replace x squared dx with 1/3 du, and so then we have u to the 5th times 1/3 du. Now the limits of integration, 0 and 2, they apply to the variable x. When we do the U substitution, the limits of integration change because we got to find them for the variable U. Well, so here down here we find the new limits of integration using the equation U is equal to x cubed plus 4. When we put in 0 in for x, we have U is equal to 0 cubed plus 4, which is equal to 4. And then we put in 2 in for x, and we have u is equal to 2 cubed plus 4, which is equal to 12. So the limits of integration are 0 and 2 for the variable x, and the limits of integration are 4 and 12 for the variable u. And so now we can evaluate this definite integral, and the value of this definite integral equals the value of our original definite integral. So we pulled the 1/3 out front. It's a multiplicative constant. And now we got to find the antiderivative u to the 5th, which is equal to 1/6 times u to the 6th. And now remember the bar with the numbers just reminds us what the limits of integration are. 1/3 times 1/6 is 1/18. And so we put in the upper limit of integration 12 in for u, and we have 1/18 times 12 to the 6th power. And then we subtract and put in the lower limit of integration for u, and we have minus 1/18 times 4 to the 6th power. And now this is just arithmetic, and using your calculator, the value of this arithmetic expression is 165,660.4 to 1 decimal place. And so the value of our original definite integral up here is equal to this number right here. All right, class, and now continuing with example 2, we got to evaluate the definite integral from 0 to 1 of the function x cubed over 1/4 times x to the 4th plus 1 with respect to x. Well, if you look in the denominator, the derivative of the denominator, 1/4 times x to the 4th plus 1, is just equal to x cubed. Well, we have the x cubed up here. So we can apply the U substitution method. So we set U equal to the denominator, 1/4 times x to the 4th plus 1. The derivative of U with respect to x is equal to x cubed. And then we multiply both sides of that equality by dx. The dx is canceled on the left, and we have du is equal to x cubed dx. All right, so now this quotient up here can be written as the product of two quotients, as 1 over 1/4 times x to the fourth plus 1 times x cubed over 1, and x cubed over 1 is just x cubed. And now we do the u substitution. We replace 1/4 x to the fourth plus 1 with u, and so we have 1 over u, and then we can replace the x cubed dx with du. So we end up with a definite integral of 1 over u with respect to u. Now, the limits of integration, 0 to 1, apply to the variable x. We got to find the limits of integration for the variable u. So down here, we do that using our equation here for u. And when we plug in 0 in for x, we have u is equal to 1/4 times 0 to the fourth plus 1, which is just 1. And then we plug in 1 in for x, and we get u is equal to 1/4 times 1 to the fourth plus 1, which is equal to 5/4 as a fraction. So the limits of integration for the variable u are 1 and 5/4. Well, the antiderivative of 1 over u is the natural log of u, right, from the basic rules of antidifferentiation. And the limits of integration, right, are 1 and 5/4. So we plug in the upper limit and we get the natural log of 5/4, and then we subtract and put in the lower limit and we have minus the natural log of 1. Well, the natural log of 1 is just 0, and so this is just equal to the natural log of 5/4. So the numerical value of our original definite integral is equal to the natural log of 5/4. All right, class, so let's move on to example 3 at the bottom of the page. And we got to find the definite integral from -1 to 1 of x times e to the x squared plus 5 power with respect to x. Well, if you look at the exponent on the number e, x squared plus 5, that derivative of that is 2x. We have the x, we don't have the 2, but we can still use the u substitution method. So we set u equal to x squared plus 5, then derivative u with respect to x is equal to 2x. Multiply both sides by dx, and we get du is equal to 2x dx. Divide both sides by 2, and we have 1/2 du is equal to x dx. So in our original definite integral up here, right, we can switch the order of multiplication in the integrand, and we have e to the x squared plus 5 times x to the dx dx. Now we do the u substitution, replace x squared with u, and we have e to the u, and then we replace x dx with 1/2 du, and so we have the definite integral of e to the u times 1/2 with respect to u. Well, you know, now we got to change the limits of integration, right? Because -1 and 1 apply to the variable x. We got to find the limits of integration for the variable u. And so down here, I find the new limits of integration using our equation up here for u. And when I put in -1 in for x, I have u is equal to -1 squared plus 5, which is equal to 6. And when I put in +1 in for x, I have u is equal to 1 squared plus 5, which is equal to 6. So the limits of integration for the variable u are 6 and 6. Now, from experience, what I know what this means is the value of this definite integral is going to equal 0. Whenever the limits of integration are the same, the upper and the lower, the value of the integral is definite integral is going to be equal to 0. But we'll show that. So we move the 1/2 out front of the integral sign. It's a multiplicative constant, and we have 1/2 times the definite integral from 6 to 6 of e to the u with respect to u. But the antiderivative of e to the u is just e to the u. And so we have 1/2 e to the u, and then we're evaluating that at 6 and 6. Well, when we put in the upper limit of integration, we get 1/2 e to the 6, and then we subtract and put in the lower limit of integration. So we have -1/2 e to the 6, and you know anything minus itself is just equal to 0. So the value of this definite integral up here, our original definite integral, is just equal to 0. And remember, in all three examples, when we did the anti-differentiation, we left out the plus c because the arbitrary constant plus c always cancels after you substitute in the upper and the lower limit of integration.